To my video lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikari, Dharmaburi. In this video lecture from upcoming semester Thermal Engineering 2, Unit 5, Refrigeration and Air Conditioning System, Module 1. From that introduction about the refrigeration cycle. First of all, you know about the little bit about the vapor compression refrigeration cycle. From this cycle is generally used for in your refrigeration and air conditioning unit. From the process of the working principle of the vapor compression refrigeration system is from the this vapor is at low temperature and low pressure, it will be entered to the compressor. From the evaporator, there is a low temperature and low pressure vapor is entered to the compressor. From the compressor, that vapor is compressed. It will be delivered from that compressor. That is high pressure and high temperature vapor is goes to the condenser. From that condenser, that is a generally you know about the condenser function is heat exchanger. From here, that with the help of that pump of water or air medium, we have to cool this hot vapor, hot temperature vapor and hot temperature vapor. Again that vapor is goes to the receiver tank, that is a high pressure tank. Generally you know about the vapor compression, there is a two side. From that left hand side low pressure side, from the right hand side high pressure side. That liquid refrigerant is entered to the receiver tank. After with the help of that expansion valve, that liquid is goes to the evaporator. It will be surrounding, they creating the chilling effect in the refrigerator or freezer or in the surrounding room. We get the chilling effect from the evaporator section only. Next slide, we have discussed about the introduction about the refrigeration. The mechanism is used for the lowering or producing low temperature in a body or space whose temperature is already below the temperature its surrounding is called refrigeration system. From this system, here the heat is being generally pumped from low level to the higher when it is rejected at high temperature. What is mean by refrigeration? Mean it is the process of measuring, modifying the temperature, maintaining the temperature of the confining space lower than the surroundings from the temperature from the room. For example, from the room we have to less surrounding below the level. How it is different from the cooling means the cooling is the process from the heat transfer to the high temperature to the low temperature. So already I told about you that is a refrigeration is from that high temperature to lower temperature from the surrounding of the room. So after that we have discussed about the objectives of the refrigeration. The main objective of the basic operation of the refrigeration and the air conditioning system, the principal components of the refrigeration and the air conditioning system, and also thermodynamic principles of refrigeration cycle. After that, safety consideration. Next slide, we have discussed about the already we have to previously we have discussed about the high pressure side and low pressure side. From the high pressure side there is a compressor, condenser and expansion valve, and from the low pressure side that is expansion, evaporator and compressor. Here the low pressure vapor is entered to the compressor. From the compressor, that is a deliver from the high pressure superheated vapor is going to the condenser. The condenser is a heat exchanger process. After it will be delivering the high pressure subcooled liquid is goes to the receiver tank and also expansion valve. The cycle is repeatedly from that 360-degree process. Next slide, we have discussed about the term refrigeration may be defined as the process of removing heat from substance under controlled condition. It also includes the process of reducing the heat and maintaining the temperature of your body below the general temperature of its surroundings. In other words, the refrigeration means continued extraction of the heat from a body whose temperature is already below the temperature of its surrounding. The main important point from the refrigeration and air conditioning system, that is a COP value. The COP value is a best value is denoted for the refrigeration and air conditioning system. That is a coefficient of performance. That coefficient of performance is is a measure of efficiency of a refrigeration cycle and also system. It is the ratio of refrigerating effect to the energy spent. The refrigerating effect is the amount of heat removal and absorbed from the substance to be cooled. The energy spent may be in the form of work in the VC or variable compression ratio or variable absorption refrigerant. Before we go to the refrigeration cycle, first of all, you should know about what is meant by Carnot cycle and also reverse Carnot cycle. From that Carnot cycle, we have to using for the power generation process, four process. From process 1 to is a adiabatic compression process. From process 2 to 3 is a isothermal heat addition process. From process 3 to 4, isentropic expansion process. From 4 to 1, that is a constant temperature heat rejected process. From that Carnot cycle transfer to the TS diagram. From the TS diagram, that is a process 1 to, that is a reversible adiabatic process, that is a constant entropy. From process 2 to 3, constant temperature process. From process 3 to 4, expansion process, that is a total work output. And process 4 to 1 is a heat rejected process. Before, that is a imaginary cycle for the power generation. According to the second law of thermodynamics, no power generation cannot for more efficiency of power generation. That reverse Carnot cycle is a comparing for the performance cycle and also using for engine performance and find thermal efficiency. Before, from the engine we have to find out the performance, and that is a main thing is thermal efficiency and brake specific fuel consumption. So the every engine we have to denote from the performance value is thermal efficiency and brake specific fuel consumption. From that reverse Carnot cycle, the process 1 and 2 is a adiabatic compression process of the working fluid with aided external work. The temperature of the fluid rises from T2 to T1. The process 2 to 3, isothermal compression process of the working fluid, during which heat is rejected at a constant high temperature T1. From process 3 to 4, adiabatic expansion of the working fluid. The temperature of this working fluid falls from the T2 to T1. Finally, from process 4 to 1, that is isothermal expansion process of air, where heat is absorbed at low temperature T2 from the space being cooled. From the process of reverse Carnot cycle based upon the TS diagram, from process 1 to 4, that is heat will be added. From process 4 to 3, the compression fluid takes place. From process 3 to 2, cooling will be takes place. From process 2 to 1, expansion of the fluid will be takes place. From that reversed Carnot cycle, we have to find out the net effect is transferred from heat lower temperature to higher temperature. This cycle will be produced for the refrigeration effect. Before we go to discuss about the refrigerator and heat pump, first of all you should know from the practical purpose, that is a method of refrigeration is, first one is a ice refrigeration system, second one is a dry ice refrigeration system. This system is very popular for food processing industries, and also it is useful for the transport mode to one of the food product from one place to another places. That dry ice refrigeration is a solid carbon dioxide. Third process is a evaporative refrigeration process. Generally, this type of system in India is useful for the, we have to cooling water is pumped from the north side direction. And also fourth process is the expansion process. From that last process is expansion of air. Finally, we, that is a throttling of gases. That is throttling of gases is a generally Joule Thomson coefficient. We very well know about from the lower side of this entropy, that is a, we get the Joule Thomson effect is from the last one is a vapor compression refrigeration cycle, last one is a steam jet refrigeration cycle. Generally, that is a air refrigeration cycles are used for that that Joule Brayton cycle or Bell column cycle or COP of the Bell column cycles. From that refrigerator and heat pump, from that cold space, from the refrigerator space is going to the desired output is going to the, from the working net output is required from the net unit. From that, after it will be dissipated to the warm environment. The same process happening on the heat pump also. From the heat pump, the transfer of heat from a lower temperature region to the higher temperature, one requires special device is called refrigerator. Then and also the another device is transferred heat from a lower temperature medium to temperature in the one is the heat pump. Generally we have to using the pump the water with the help of the pump to lift the water from lower level to higher level. The same processes happen on the heat pump also, from the cold environment to cold environment pump with the hot environment. From the COP from the refrigerator is desired output by required input. From the desired output is a cooling effect, required input is work input. From the COP from the heat pump, the desired output is by required input, the heating effect by work input. Finally we get the COP of the heat pump is equal to COP of the refrigerant plus 1 for the fixed values of low heat and high heat temperature. The refrigerator and the refrigerator is reverse heat engine or heat pump which takes place out heat from cold body and delivers it to hot body. The refrigerant is a heat carrying medium which during their cycle in a refrigeration system absorb heat from lower temperature system to deliver its higher temperature system. The unit of refrigeration is very important. The ton of refrigeration is generally we have to using from that ice plant. We have to calculate from the refrigeration is that is a ton of refrigeration. From the 1 ton of refrigeration is 3.5 kilowatt. The capacity of the refrigeration unit is generally expressed in the tons of refrigeration. The rate of removal of heat is cooling operation was expressed in the term of kilograms or tons of rice required per unit time usually or a day. From the 1 ton of refrigeration is used from the 24 hours and also 38 degree Fahrenheit. We have to calculate that 1 ton of refrigeration. Generally from India, that is 1 ton of refrigeration is 3.5 kilowatt we required. 1 ton of refrigeration, the quantity of heat required to remove from 1 ton of ice with 24 hours with initial condition of water is 38 degree Fahrenheit, that degree centigrade, because the same cooling effect will be given by the melting the same ice. From that refrigeration system is used for the various application, that is a cooling of food storage and cargo, cooling of electronic spaces and equipment, from that computers and consoles, radio transmission system, radars and sonars, and air conditioning for crew comfort. From particularly from the India, there is a winter and a summer and a various season period. From that summer period very essential for the refrigeration and the air conditioning system. And also the refrigeration is used for various application in the worldwide. It is a very without refrigeration the world is not to running. So the refrigeration is very essential for in our household purpose, and also human beings. The refrigeration is used for various products. So that is a very good technology to implement it from that refrigeration system nowadays. Next we have discussed about the refrigeration cycles. That is a refrigeration cycles are where the vapor compression cycle and the vapor absorption cycle. From the this rejection of heat from lower level to higher level temperature can only performed with the help of external work according to the second law of thermodynamics. The total amount of heat being rejected the outside body consists of two parts: the heat extracted from the body to be cooled, the heat equivalent to the mechanical work required for extracting it. Thank you.